Hi there, I'm John from CNCKing.com, and today we make custom HDPE jigs. When it comes to making custom jigs here in the shop, we've been doing it for years. But this is the first time we actually start going into the harder plastics or different kind of options, especially when it comes to UV printers. Now in this case here, this is for a UV printing project, and you can see where they put their stuff in here. And this starts off as 3/4 inch HDPE, but by the time the machining is done, the flattening, all that kind of stuff, it loses about 1/3 of its height. So it's pretty incredible how much machining goes into something like this here. And the reason why we're doing this, because HDPE is never dead flat. It's always warped in one way or another. And when you're using a UV printer especially, with the laser we have tolerances, we have tolerance with all the machines here, but with UV printers, you're really limited by how much tolerance you have between the printer head and the substrate that you're printing. Now another thing you'll notice is this is actually black. Now HDPE is generally white. That's the kind of stuff you see at the dollar store. They're used for cutting boards. In this case here, if you use white, it absorbs a lot of the UV and it causes issues production-wise for the customer. So with black, you don't have that issue because a lot of it reflects back. Now as you can see here, it's totally dead flat in every dimension. And I also scored the back of it, because what happens is that because you only have one side machined, it tends to want to slightly curve up. Now we're talking about fractions of a millimeter or like 1/32 or something like that. But it took a lot of time to get this sorted out so that it's dead flat, and part of that is scoring the back to make sure that it stays that way. When it comes to making custom jigs, we literally made them out of any material you can imagine. In this case here, we're using HDPE, which is the black stuff you see here. Now HDPE is a very durable material. It's a very strong material. You might actually see it when you go to the dollar store and you get cutting boards, very cheap ones. That's what it is. This HDPE, of course, costs a lot more than the cheap stuff you find in the dollar store because it's a lot thicker and it's a lot more traceable, meaning the material itself has a material data sheet, so it's made in North America and so forth. So for this specific job here, what I'm doing is shaving off the warping on the actual HDPE. And the HDPE comes in large sheets, 4x8 or 5x10. And the problem with that is that it's not dead flat. Now for most applications, let's say a cutting board, it doesn't really matter because the cutting board is so small that you don't notice the warping in it. And the application that you use it for, it doesn't really matter if it's warped anyways, you're just cutting vegetables and meats. Not a big deal at all. But when it comes to UV printing, if you have a project that you're doing and what happens is, let's say, I don't know, you're making phone cases. And the phone case is up or down on the Z axis, let's say 3 or 4 millimeters. Well, now you're gonna have a problem with UV printing onto those phone cases, because the UV printing process is very specific regarding tolerance. It's not as specific, let's say, as lasers or routers or that kind of stuff, but it's pretty specific. And the additional issue with UV printers is that some of them, not all of them, but some of them also cure it on a secondary pass. What that does is actually introduce some heat and some other chemical reactions that could possibly happen on the jig itself. Now at CNCKing.com, most jigs I make or either acrylic or MDF. Sometimes I make them out of other materials, but those are the winners so far for everything. For this specific project, we could not use acrylic because it wasn't durable enough for this application. And we couldn't use MDF because it does tend to warp over time a little bit. And this is for a high production shop. And the high production shop needs jigs that work 24/7, 7 days a week. And they need it to work perfectly, and they can't have any warping over time. So going with HDPE, as you see here, is what we used. We also looked at other materials, such as Delrin, and that was a close second, but the cost of that is even more ridiculous than HDPE. Another material option would have been Corian, and the only problem with Corian is that it's very brittle and very heavy, but for this application here, those were two things that we could not have. Now the nice thing about HDPE is that it machines incredibly well with our CNC router. We can't use the laser for this stuff because it's too thick and it'll just burn up and cause lots of issues. But with the router you can see how it just does all the machining great. Now you notice there's holes in here as well, because sometimes what happens is you have your stuff on here, and for some reason, reason or another, maybe some UV ink or what have you, and it gets stuck. So if you have holes in the back, that means you just go like this with a pencil or even your pinky finger and push it out. So you're not here trying to scratch your way into it, and you have a really nice jig as a result. Now a couple other things to keep in mind is this jig is exactly the size of the piece. So you notice the edge, it's right on the edge here. That's because what they're putting in here is right on the edge. And that's an important feature because we made 2 of these, and you want them to be able to fit into the machine. So as you can see here, you feed it in, and as a result, all the spacing, everything has to be identical all the way across the board. So it has to be identical X, Y, and also Z. And that's another reason why I lost so much height during production, because I can't go any higher than the lowest point. What I mean by that is, this one here, when I machined it, it was a little bit less thick than this one here. So I can't add material to this, so that means this one here has to match this. In addition to that, I also have to machine it down just a little bit more, just again to make sure it's totally dead flat, because between the time of flattening this initially, cutting and flattening it, to actual production, things can sometimes move a little bit on you, and I just want to get rid of that completely. Now for here, I've been flipping the board back and forth over and over again, just to get out the warping. It's kind of challenging because I cannot use the vacuum system to hold it down, because what the vacuum system will do, it will pull the HDPE down flat, which is what I want. The problem is when you machine it there, then you turn the vacuum system off, it pops back up. And we're talking about millimeters, like very fractions of a millimeter, and we can't have that happen. So everything here has to be held down manually. You'll see in each of the corners, you'll see screw holes. So this is screwed down, and again, every time I flip it over, I go back over it over and over again. Now, there's another challenge with HDPE in that, or generally most plastics, but especially HDPE, when you work on one surface, the other surface underneath that you're not working on will tend to want to warp upwards, in this case here. So for instance, the top here, we're cutting out all the little pieces that the customer will be doing their HDPE UV jig printing with, and all of this here will tend to warp upwards because the bottom is not machined. That's just the way plastic works. Now, if we were doing this out of Corian, it wouldn't be an issue because it's very rigid, but HDPE is somewhat semi-rigid, flexible a little bit, and that's why you have that issue. So what I'm doing here is doing the jig one after the other. Did a couple of jigs, and we're testing out a couple of things. Again, this is just a prototype of a main production, so we're just making sure everything works spec-wise. The router is not going very deep. It's only roughly an eighth inch deep, or roughly 3 millimeters. And the overall jig is roughly 14 millimeters thick. It starts off at 19 millimeters, so we lose actually about 5 millimeters, which is quite a bit. It's half a centimeter of material is removed during this whole process here to produce the jig. Now, again, you can't use vacuum for any aspect of this project. So you got to be very dead on, make sure everything's totally dead flat. And the way you know that is when you lay it on the board, when you lay the HDPE flat on the router, it actually sort of sucks down. It's kind of strange. There's no suction. That's how dead flat this thing is. So if you're looking for custom jigs, we make them out of literally any material. I use them here in the shop all the time, whether it's MDF, acrylic, HDPE, what have you. We can also make metal jigs as well. Contact me at CNCKing.com. We'll make it for you and ship it right to your door.